Hello, and welcome to another Common Core Algebra 1 lesson by eMathInstruction. My name is Kirk Weiler, and today we're going to be doing a lesson on percents. And this is a very basic lesson. In fact, it probably includes material that you learned back in 6th and 7th grade in middle school Common Core math. But you're going to be doing a lot more percent work this year in Common Core Algebra 1. And I want to make sure that you've got the basics. All right, so this is an add-on lesson to our curriculum. It's not one that you would find in one of our workbooks. And let's go ahead and take a look at what a percent is. All right, what is a percent, right? A percent is a ratio of two quantities expressed as a fraction out of 100. You see, we have to deal with fractions all the time, especially when we're talking about the proportion of a whole that something is. You know, when we talk about 32 out of 60 people owning cell phones, or 2 out of 3 voters preferring a particular candidate, right? The big difference is a percent is a fraction or a portion that is always expressed out of 100. All right, and in fact, that's actually in the name percent itself. If you take a look at the word percent, per plus cent is per 100, right? So when I talk about 79%, I'm talking about 79 out of 100. When I talk about 25%, I'm talking about 25 out of 100. The real question is, when you don't have a total of a 100, then how do you figure out what the percent is? So let's take a look at that in our first exercise. Okay, in exercise number 1, we're told if 15 out of 25 people called in a survey own cell phones, then what percent of those surveyed own cell phones? Show how you arrived at your answer. And the idea here is, okay, we've got 25 people and 15 of them own cell phones. But if instead of 25 people, we had 100 people, then what would be the number of people that own cell phones if it's the same ratio? All right? And what we're really trying to do is exactly that. We're really trying to say, look, if I have 15 out of 25, right, then that is what percent out of 100, right? That's what we're trying to do, and that's what a percent tells us. If we've got 15 out of 25, that's the same as what out of 100? Well, one common way that you can manipulate percents, and again, this is at a very, very basic level, is to take this fraction and turn it into a fraction out of 100 instead of a fraction out of 25. Now that's simple enough to do by just multiplying the numerator and denominator of this fraction by 4, just a common little manipulation, and what we would get is 4 times 15, which is 60, 4 times 25, which is not 200, but 100. And now what we see is we see that the percent is 60%. All right? So in other words, 15 out of 25 is the same ratio as 60 out of 100. So we'd say that 15 out of 25 is 60%. 60 per 100. So it's that simple, all right? And let's play around with this for a few more exercises. All right, let's take a look at exercise number 2. Let me read it off for you. If we know that 30% of all students take pre-calculus in a certain school, and there are 500 students in the school, how many of them take pre-calculus? Now again, understand this in a very, very basic level. If I tell you that 30% of all students take pre-calculus, that would mean that if I had 100 students, 30 of them would be taking pre-calculus. 30 per 100. But I don't have 100 students, I have 500 students. In that case, of course, what we're kind of doing is we're thinking about this proportion. 30 out of 100 is equal to x out of 500. And again, we could use a common algebraic technique like cross-multiplying to solve for x, but this fraction is easy enough to manipulate so that it has a denominator of 500. So what I could do, just kind of like I did in the last problem, is I could multiply both of these by 5. What that would give me then is 150 out of 500 equals x out of 500. And therefore, there are 150 students who take pre-calculus. And again, this is just simple proportion work. Simple in quotes, right? Because we're still dealing with fractions, and fractions can be very challenging for people. But again, what we're saying is that 30 out of 100 is the same as 150 out of 500. So 30 out of 100, right? 150 out of 500. So 150 students is 30% of 500. Let's keep going. All right. So exercise 3 is simply a series of exercises that give you a chance to try to play around with figuring out percents or doing percent work by expressing equivalent fractions out of 100. What I'd like you to do is pause the video now, attempt problem A, and then we'll go through it, and we'll continue to go through each one of the problems in this particular exercise just like that. Take a moment, pause the video now. All right, let's go through the first problem. Letter A, if Samuel wants to leave a tip of 15% on a bill of $20, how much should he leave in tip? Okay, now again, understand this from a basic perspective. If for some reason Samuel racked up a $100 bill, he would want to leave $15, right? 15% means if the total is 100, then 15 parts of that would be, of course, 15. But we don't have a bill of $100, we only have a bill of $20. So the idea again would be 15 out of 100 is equal to what out of 20? And again, to really figure out this x, all we really have to do is manipulate it. All we have to do is manipulate it so that this fraction and this fraction look the same. Now you could do that in one of two ways. You could either multiply both numerator and denominator here by 5, all right? Or you could actually divide numerator and denominator here by 5. Since we've been sticking with the idea of multiplication, let's do that. Let's multiply by 5 here and by 5 here, and that'll give me 15 out of 100 is equal to 5x out of 100. Now, this is a little bit tricky because it involves just a bit of algebra. That means that 5x must be 15. Do a little bit of simple division by 5, and x must be 3. So we should leave a tip of $3. In other words, 3 out of 20 is the same as 15 out of 100. All right? So 3 is 15% of 20. That's simple, sort of. Let's take a look at letter B. All right? Yet again, I'd like you to pause the video and work through the problem. All right, let's go through it. If Elliot scored 42 out of 50 on her quiz, what percent score did she earn? All right, so again, what we really want to know is if instead of taking a 50-point quiz, Elliot took a 100-point quiz, how many points would she get? How many points per 100 would she get if the ratio of 42 out of 50 kind of stays constant? All right, so again, we're sort of thinking about it this way. 42 out of 50 is equal to what out of 100? All right? Now, this is a very, very simple manipulation because if we want to be able to compare these two fractions easily, then we want both of their denominators to have a 100, and that's simple enough here because we can just multiply both numerator and denominator by 2, giving me 84 out of 100 is equal to p out of 100, and so the percent is 84. All right? And again, just to keep emphasizing this idea, 42 out of 50 is the same proportion as 84 out of 100. Therefore, 42 out of 50 is 84%. 84 per 100. All right? Let's keep going. Letter C. Again, pause the video, make an attempt at it, and then we'll go through it. All right, let's do it. Letter C, Malia's weekly pay increased by $40 from $200 to $240. What was the percent that Malia's pay increased? Now, this can be very, very challenging for people. right? But basically what I'm saying is, look, I've got $200 and my salary, or Malia's salary, went up by $40. What percent is 40 out of 200? Okay, that's what I'm looking at. 40 out of 200. 40 is how much it went up. 200 is what it started with. Now, some people might say, well, why do you have 40 here and not and 200 down here instead of 40 and 240? And that's because, look, if I'm sitting with a salary of $200 and somebody says, I'm going to give you a 5% raise, let's say, well, then the plain fact is they're talking about 5% of that 200. They're not talking about 5% of what my eventual salary will be. So I'm saying, what proportion out of 100 is 40 out of 200? Right? 40 out of 200 is the same as what out of 100? Now, what's really cool is you can most certainly reduce this fraction, if you want to get it to be out of just 200. Or sorry, just out of 100. You could easily divide both of these by 2, giving me 20 out of 100. And therefore, right, Malia's pay went up by 20%. 40 out of 200 is the same as 20 out of 100, so Malia's pay went up by 20%. $20 per $100, right? It went up $40 out of 200, so that's $20 out of 100. It went up 20% per 100. Let's keep going. All right. Why don't you go ahead and read over problem D, take a minute or two to solve it, and then we'll come back and take a look. All right, let's do it. Problem D, Sebastian collected 8 stars on a video game level. The 8 stars were 32% of the total available. How many total stars were available? Now this can be very tricky for people, right? Basically what we're saying is if 100 stars were available, then Sebastian would have gotten 32 of them. But we don't know how many were available, but we do know Sebastian got 8. So again, understand this 32%. If there were 100 stars in total available, Sebastian would have collected 32. On the other hand, there weren't 100 stars available, there was some unknown amount available, but Sebastian was able to get 8. So what we're really thinking about here is 32 out of 100 is the same as 8 out of what, right? So this is a little bit trickier, right? Because we're looking at this now and going, oh, 32 out of 100 is the same as 8 out of what? Now, we could either make that 8 into a 32 by multiplying the numerator and denominator by 4, or we could make this 32 into an 8 by dividing this numerator and denominator by 4. Either way, remember one golden rule about converting between equivalent fractions. You can multiply or divide the denominator and numerator by anything you want, as long as you do it to both, all right? Multiply the top and the bottom by a fraction by 5, that's great. Divide the top and the fraction by 3, fine. Don't add or subtract to the top and the bottom of a fraction, to the numerator and denominator, but multiply and divide by as much as you want, as long as you do it to both. So in fact, what I'm going to actually do is I'm going to divide both of these by 4, and I'm going to get 8 out of 25, right? And now a simple comparison, 8 out of 25 is 8 out of x. That means there must have been 25. 25 total stars, right? Again, it's very simple. If Sebastian had 100 total stars that he could have collected and got 32, well, that's the same as 8 out of 25. Since this is actually what he collected, there must have been 25 stars in total. Okay, per 100. Now, all of the problems we've worked with so far, it's been relatively easy to set up a proportion. And remember, a proportion is simply an equation that sets two fractions equal to each other. And then we've been able to manipulate one side of the fraction or the other in order to be able to figure out what we're missing, the percent, the total, the part, what have you. But of course, percents don't have to work out all that nice, right? So let's take a look at what happens if the ratios are not easily converted to fractions out of 100. Okay? Let's take a look at exercise number 4 together. Keenan collected shells on his recent trip to the beach. Of the 65 shells he collected, 40% of them were chipped. Okay, so this is the total number of shells he collected. And he collected 40% of them were chipped. All right, first, how many of the 65 shells were chipped? Set up and solve a proportion to find the answer. And again, just making sure that we understand the basics. If Keenan had collected 100 shells, 40 of them would have been chipped. But Keenan didn't collect 100 shells. Keenan collected 65, right? So just like before, right, we know that 40 out of 100 should be the same as what out of 65, right? Now, unlike the other problems that we did, it's not so easy to multiply the top and the bottom of this fraction by something to turn a 65 into a 100. If that 65 is a 25, a 50, a 100, a 20, a lot of different numbers, right? Then it's not so hard to do. But this is kind of ugly. So what we now do is we bring in the age-old technique of cross-multiplying. In other words, what I'm going to do is I'm going to cross-multiply these, and I'm going to get 100x equals 40 times 65. And that's, of course, what my handy-dandy calculator is here for. We don't need any fancy graphing calculators in today's lesson. We just need something that can do some basic multiplication and division for us so that we don't have to think so hard. And in fact, right, we just, 40 times 65. That didn't work. Let's clear that. Let's try again. 40 times 65 is 2,600. So 100x equals 2,600. And now, of course, we could divide by 100 on both sides. And x, whoops, where's my division? Divided by 100, which I hope you could do without the calculator, but x would be 26. Now again, make sure, 26 out of 65 is the same as 40 out of 100. So 26 of these shells are chipped. Let's take a look at letter B. Of the shells that were chipped, 20 of them were white. Of the shells that were chipped, 20 were white. What percent of the chipped shells were white? Set up and solve a proportion to find this answer, round to the nearest percent. Okay, so now our total, what we're really thinking about, is no longer the 65 total shells, but just the ones that are chipped, and that's 26 of them. And 20 of them happen to be white, right? So 20 out of those 26 shells that are chipped happen to be white, and we want to know what that is out of 100, right? So 20 is to 26 as what is to 100. And again, not so easy to convert 26 into 100 or vice versa. So we simply do some cross-multiplying. All right, in this case, we get 26x, right? We do 20 times 100. Again, I hope a problem like that is relatively easy to do in your head, but in case it's not, right? We get our 2,000. I divide both by 26. And I get 76.92, etc., round to the nearest percent. That's going to be 77%. All right. 20 out of 26 shells being white is almost the same as 77 out of 100 shells being white. Okay? Pretty simple. But messier than before. Now, just for the record, of course, all the problems on this previous sheet we could have also solved by cross-multiplying. We could have definitely in sort of letter A just said, all right, I'm going to do 20 times 15 and 100 times x, and then I'm going to divide both sides by 100, and I'm going to figure out what x is. But in these problems where it's kind of easy to mentally manipulate the fractions so that we get it out of 100, it's kind of nice to be able to do it that way so that you really kind of get at this idea that you're really just looking at proportions out of 100, or ratios out of 100. On the other hand, when that's not so easy to do, and we have to bring in calculators and messy writing, well, then that cross-multiplication algorithm is very, very helpful. Anyway, pause the video now and take a look at the screen, write down anything you need to, and then we'll move on and do a few more practice problems on this. Okay, let's move on. All right. This last set of problems, kind of like that set on the front side of the sheet, is just to give you more practice with manipulating percents, all right? And all of these, in my mind, kind of need to do the cross multiplication, and you probably will want to have a calculator on them, all right? So here's what I'd like you to do now, all right? Since we've done quite a bit of work on percent, I'd like you to pause the video now and take as much time as you need to go through every single one of these problems. Then we'll read through each one of them and go through them in turn, okay? Take a little while to work through these. All right, we're back. Let's go through them. Exercise number 5, set up and solve a proportion for each of the following problems. Letter A, Kirk. Kirk scored a 65 on his recent French test. I was never very good at French. Kirk scored a 65% on his recent French test. If there were a total of 80 points, how many did Kirk earn on the test? Now again, don't get me wrong, if you know a different way to do this problem, great. This lesson is on basic percent work. So what I know is that if that test was 100 points, I would have scored a 65 on it. But it isn't 100 points, it's only 80 points. And the question is, what did I actually score? So 65 out of 100 is what out of 80? And I need to figure out what that what is. What the what is. All right, so now what I'm going to do is I'm going to cross multiply. Okay, I'm going to get 100x is equal to 65 times 80. And that's going to be 5,200. And then I'm going to divide both sides by 100. And now I think I'll skip the calculator work to get x equals 52. So I must have scored a 52 out of 80, because 52 out of 80 is the same as 65 out of 100. All right? Let's take a look at problem letter B. Lorelei has used up 35% of her total download memory allowance. If she has downloaded 77 gigabytes of data, what is her total allowance? 77 gigabytes is a lot of data these days. 2 years from now, it's probably going to be like, really? 77 gigabytes? Anyway, Lorelei has used up 35% of her total download memory allowance. If she has downloaded 77 gigabytes of data, what is her total allowance? We're looking for the total. And again, think about it this way, right? If for some reason the total, right, was 100 gigabytes, then she would have downloaded 35 of the gigabytes, right? But we don't know what the total is, but we do know that she's downloaded 77 gigabytes. So in other words, 35 out of 100 is the same as 77 out of what? Right? So 35 out of 100 is the same as 77 out of what? All right, well, I just do a little bit of cross multiplying again. We'll get 35 times x is equal to 7,700. I'm not going to do that one on the calculator. But then I can divide both sides by 35. All right, and I need my calculator now for that. 7,700 divided by, wow, I think I just hit plus. Let's do 7,700 divided by 35 equals 220. All right. And again, going back to those equal ratios, right? Those proportions. 35 out of 100 is the same as 77 out of 220, right? It's that simple. Okay, let's take a look at another. Of the $124 weekly grocery bill, May paid $84. To the nearest percent, what portion of the bill did May pay? All right, so we know that May paid 84 out of $124, but we want to know that if the total actually had been 100 instead of 124, how much would have May paid, right? That's going to be her per 100, per cent, all right? So 84 out of 124 equals what out of 100, right? That's all we're doing. And again, Nice little cross multiplying. Nothing really too mentally stressful here. 124x equals 8400. Divide both sides by 124. And x will equal 8400 divided by 124. 67.74, etc. I didn't say what to round here to, I should have, but we'll just round to the nearest percent. May paid 68%. So 68 out of 100 is the same as 84 out of 124. If the total bill had been $100, May would have paid 68. The total happened to be 124, so she paid 84. All right, one more problem. This is probably the trickiest of them all, okay, because it has to do with percent increase, but let's take a look. The incoming freshman class at Arlington High School dropped by 20% from 2014 to 2015. If the incoming class had 750 students in 2014, how many students did the freshman class of 2015 contain? Now, I really want you to make sure that you understand this. Okay, because this is actually sort of a two-step problem. We're going to have to find an answer, and then we're going to have to find another answer, right? Now let's kind of get this, though. It says the incoming freshman class at Arlington High School dropped by 20% from 2014 to 2015, okay? Now understand that. That means that if the incoming class had 100 students, then it would have gone down by 20 out of 100, and then in 2015, we would have obviously had 100 minus 20, or 80 students, okay? But we didn't start with 100 students, we started with 750 students. So the first thing that we have to do is figure out what is 20% of 750, all right? So we know that we've got 20 out of 100, and we want to know what that is out of 750, all right? Because that's the number that our population is going to drop by. We're going to get 100x is equal to 20 times 750. Sorry that that kind of got a little bit blotted out there. And that's 15,000. And then I'm going to divide by 100. And I'm going to get x equals 150. Now keep in mind what that 150 really is, because this is where it can get quite tricky. That 150 is not the answer, right? The 150 is the 20% of the 750. That's how much the population of the incoming class at Arlington High School is going to go down. So what we have to do to actually figure out how many students the freshman class of 2015 had, we would have to take 750 and subtract off the 150, and we would be left with 600. All right? And that's it. All right. So let's wrap it up. You're going to do a lot of work with percents in Common Core Algebra 1, and you're going to find percents many times in ways that are faster than what we did today. But oftentimes when you get into high school math and you're doing work with percent, you can kind of lose the essential idea. That is that percent represents a comparison of two things where the total is out of 100, right? And we've seen a variety of problems today where you've got some kind of total that isn't 100, and then you establish an equality between that ratio and a ratio out of 100, and then you solve for whatever you're missing, whether that be the percent itself, the total, or the part of the total. And those are really the only things they can ask you about. All right. Well, I want to thank you for joining me for another Common Core Algebra 1 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.